Hello everyone, welcome once again to another Power BI related tutorial by Slidescope. In this part, we are analyzing air quality overview or air quality index, and we are trying to see the effect of different type of gases and pollutants that are in air and comparing them. What is their variance? What is the maximum? What is their average value? And we also have some sensor data and the reference value. So what is the relationship between that sensor value and the reference value? That is also we are seeing and drawing some insights from it. The data set that we have used here is the air quality data set from uci.edu, and here you can see uh, the device was located on the field in a significantly polluted area at road level within an Italian city, and data was recorded from March 2004 to February 2005. That is 1 year, and here we have different type of chemicals, etc. So we will explain you about data. What does this type of these fields mean, and how can we clean the data and start doing some exploratory analysis. So this is the first part. So the data set that we will use in this project is air quality measurements data set. And this data set contains detailed air quality measurement collected over several months focusing on key air pollutants. And it is designed for predictive modeling and data analysis in environmental science and public health by offering insights into concentration levels of various gases. The data set is suitable for both regression and classification tasks. So first of all, you can get the data set either from the official website or from this Kaggle uh, URL. So all the information about this data set and licenses etc. is written here. So you should read everything properly. And in the data set, we have different type of variables like date, time, CO, which is a feature, true hourly average concentration CO. Then we have PTOT, which is hourly average sensor response. Then we have true hourly averaged over non-metallic hydrocarbons concentration, etc. So we will go through these different parameters while analyzing the data. One more important thing about this data set is that data set contains 9,358 instances of hourly average responses from an array of 5 metal oxide chemical sensors embedded in air quality chemical measurement device. And as you can see, the device was located on a field in significantly polluted area at road level within an Italian city. And recordings are from March 2004 to February 2005. When you will download the CSV file, it will look like this. So here we have the CSV file. So now we will start analyzing the data, start exploring the data and finding out relationships and patterns of different type of values that we have here. Now after studying about the data set and seeing some snippet about the data set, here are some Power BI dashboard ideas for the air quality data set. And first is overview dashboard, providing a high level summary of air quality trends. So we will open Power BI. This is Power BI desktop, which is optimized for Power BI report server. If you have normal Power BI desktop, you can use that as well. It's your choice. And here we will simply connect the data set. It's a text CSV file. We will connect the air quality data set here. Now we will simply load the data set. Make sure your column and rows are there. For example, I can see after T, RH and AH, one column is there which seems extra to me. So let's transform the data in this case. And let me check. You can see these two columns are extra because last column is AH, which is short form for absolute humidity. RH is relative humidity and T is temperature in degrees Celsius. So here we will select them and delete them. Now we have all the columns here. Make sure once again, and now close and apply. This way we have made the changes in the data. It is applying, and this is air quality UCI now. And we will simply rename it in short, so that if we have to create any type of, so this, we will call it AQI or air quality index, or whatever you want to name it. Now here we have some dashboard ideas. So as per dashboard idea, we will create some visuals. That means a line chart, show pollutant level, example CO, NOx, benzene over time. First of all, you can go to view and select any type of palette that we want. Let's say we want this cool warm type of palette, and whatever palette you are choosing, you can customize the theme. Go to page visual, page background, and from here we will select a E8 E8 or E9 E9 hex code, transparency 0%, apply. We have the hexadecimal code here, and we are going to build the overview dashboard. So we will rename it as overview dashboard. In our overview dashboard, we can also add a simple text box. So from here, we will add a text box calling it air quality overview dashboard, and we will align it to center, make it full width, align to center, and make it bold. Select the font size as 28, or we can also use 32, and we will use some color from the palette which we will use as our theme color. For example, let's select this particular color as our theme color. And now this is the air quality overview dashboard. And as per our dataset discussion, so line chart showing pollutant levels. So in order to do that, see, whenever you have a date related column, so first of all, make sure that it is being read as a date value. So here, for example, you can see it is a date column, but somehow this is not being read as a date value. Okay, the data type is text here. So what we say, data category, and in data category we can use something like place, city, etc. But anyway, this is not a date value. So we can again go back to transform data, and after going into transform data, see, in case of time it is being read as time, right? So that is good. You can see a clock icon here. In date, it is saying list may be incomplete. So we will simply click here, right click here, and we will change its data type. Okay, so change to date. Now it is showing some kind of error maybe. So we have changed the type. Close and apply. Let's check. And so it is showing that in 5760 rows we have some error. And the error are because date format we couldn't pass the input provided as a date value, because it is saying the value 3/14/2014. That means date, this is month, date, and year. So the format is MDY. So first we will undo our changes. So we are you know deleting this. Here we have AQI. We change the type, so we will undo our change. We have some errors, so first of all we will delete this, because we are not going to keep the errors, and we are going to delete the group. So we will keep our data set, and now we have to figure out how to change this. Remember, in this case, if 3/10/2004 is written, this means 3 is the month, 10 is the date. So that file contains some missing date values. Okay, that's why we are having this problem. Here we can see there are some blank date values. So after looking at different sources, we have downloaded a clean data set because as per the official document, date has no missing value. So we have downloaded it from here. This Excel file can be downloaded from this zip. And now what we are going to do, we will remove this from our model and connect that file. Sometimes this happens, and first we have to make sure we are loading the correct data. So I will definitely provide you the correct file so you don't have to do this multiple times. So this time I am uploading the Excel file, and let's see. So here in the Excel file, by copying data from the original file that we had, I have simply created a Excel table, and I will provide you this file. So now we will simply load that table, the table 1, right? Here you can see date, time, everything is there. And now we don't need to transform data or clean data anymore. And we have to simply load it. Now we can see it is there. And here you can see now we have the date hierarchy, which should be there. And we will simply rename it back to AQI. So we have done our data cleaning part, and now we have the clean data. Let's go ahead with the dashboard part where we have to create a line chart showing pollutant levels, example CO, NOx, benzene, etc. So for that, we will use a line chart here, and in the line chart, we will just make the width as per our requirement. And here on x-axis, we always put date. Okay, so we can put date here, and on y-axis, we have to put, for example, NO2. Okay, we can also put CO. So this will show us different lines of different parameters, right? Currently, this is 2004 and 2005. If we go to date and we want to see monthly, right? So you can see yearly in 2004 to 2005, the sum of CO increased, right? Here it is minus 15,384. Here it is minus 30,000 or 3,04,000, right? So this has increased, but this is almost flat line. Okay, this is almost a flat line NO2 value. But if you want to see it monthly, so you can click on this and then you can drill down the data further. So you can see monthly. So you will be able to see the effects of different, you know, different type of parameters here. So you will be able to see the effect of different type of gases here in different months. For example, in the month of March, NO2 is higher, right? And similarly, in the month of February and March, some of CO2 is also higher. We can also include other parameters here. And for example, C6H6 also we can include. Just a minute. And you can see it is fairly constantly there in each month. Okay. And here we will, if you want, you can remove other parameters here. Just keep monthly. So C6H6 is total or true hourly average benzene concentration in microgram per meter cube. Reference analyzer. Okay. In these type of charts, suppose you are visualizing 3 or 4 different type of parameters, you can also select a 100% stacked area chart or a stacked area chart. Okay, this way you will be able to see the concentration, or a simple area chart also, whatever you prefer. So let's keep it as an area chart here. So now we have this, and this is our first chart here with which we are seeing, showing pollutant levels over time. Then we can create some card visuals also, display average, max and minimum value of key pollutants. So obviously we can show average, minimum, and maximum for all pollutants. But let's say we are considering CO, NOx, and benzene here. So concentration of carbon monoxide and benzene and nitrogen oxides, right? So what we are going to do, we will create some card visuals here. So first I will create one single card visual, and in one card visual I will show some parameters. And here let's say I want to show average, right? So this is sum of CO. I will say maximum, minimum, average, whatever you want to show. For example, average value, and we will just go to call out value. We will make it very small because we have to show many of them. So we can use something like 16 font size here. Okay, this is average of CO. We'll make it bold, and category label also we can make bold. Sorry for the noise. We will select this and we will enable some shadows here also. Here also we'll enable some shadows. So this is average of CO. So similarly we will create it 3 times because we have to use control C plus control V or command C plus command V as per your computer configuration. And here instead of average of CO we will use average of benzene, and this is sum of this, so we will say average of benzene, okay, which is 1.87. And here we are going to bring average of NOx or NO2, whatever you want to bring. So since here we have used NO2, so we are trying to analyze 3 different parameters here, NO2. And in one of the chapters we have also discussed about creating dynamic measures, so you can also explore that. So you can keep these measures dynamic and you can create them as a filter. But let's consider CO, benzene, and NO2 here. We will see its effect in different cases. First of all, here I will go to title, make the title bold, and title color is something that we can choose according to theme. Here also the font color is something that we can choose according to the palette that we have selected. So this kind of makes the graph a little bit better looking, and it's your choice. It's totally optional. And here also we will write average of benzene, average of NO2. So now we have average of NO2, average of CO, and average of C6H3. We can copy this and place this here, and here we can show minimum and maximum values also. So instead of average, we will say show maximum. You can see on an average it is in negative range, but max on a maximum value it is 11.90. Similarly, here also we have a maximum value, and here also we will put maximum value. This way you will be able to see the distribution of your data, right? Now here what you are seeing in the background, you are seeing a chart, okay, and on top of it you are seeing a value. So let me increase the value to somewhere around 19 or 20. Then we will be able to see the value clearly and the chart in background. How is this done? So what I have done here is, let me show you step by step. So first of all, what let's say this is C6H6, and we have to show the you know uh, the variance of C6H6 over time. Okay. So first of all, we will create a line chart or an area chart here. And after creating the line chart or area chart, we will bring, let's say, month on the x-axis, only month, and the benzene value on y-axis. You can also select stacked, 100% is stacked, or any chart that will show the distribution or variance, how over different months we have different concentration of C6H6. Here in x-axis, we will go and disable values, In y-axis, we'll go disable values and title. On the chart, we will go and disable the title because we know it is distribution of C6H6. Okay, and slowly we will make its size adjustable and we will take it just over our chart. Now we will go to format and we will send it backward. Again click on it and format, send it backward. Now it is behind. Okay. Now we will select this one which is over top in the layer and we will go and general and effect, and here we have transparency. We will slowly increase its transparency. So when you will slowly increase its transparency value, you will start seeing the chart. Make your transparency that much that you are able to see some distribution. So this will not only tell you about that value, but it will also tell you the trend of it, right? And here we will increase it to 20. So this is something that you can do in order to see the distribution, right? When you will take it away, that will be on back. So let's copy this and paste one more time. And here, this is optional, just giving you an example. You must have seen in some charts. So that's why I'm just showing you how this is done. And we will just take it over it again, format, send backward and click on it, and let's say in general affect 16% or 20%, whatever you feel, and increase its value to 20 so that we can see it properly. This is one way to display the trend of that value. Now because this is NO2, so instead of sum of C6 we have to show the NO2 value. So whatever variable you have chosen, you can show its trend. So this is very important. Obviously, readability may get affected, but this also shows the trend of data. So it is very important. And for example, you can do something like this, you know, so it will show trend as well. So now you can adjust it accordingly. So this is average, this is maximum. Similarly, you can show minimum and average also. And whatever parameter I am choosing here, for example, I am choosing average of NO2 here. So I will also select average here. So obviously not going to waste too much of difference, not going to make too much of difference, but this way you can show two different things together. So it's your choice. Okay. So obviously we have average here, maximum here. So here we can choose something like sum. Here also we can choose something like sum or minimum, because sum will not make too much sense here. So we can write what is minimum value. We can also show variance, right? So let's show variance here, like which will show us in the data set, like what is the overall variance, which will tell how closely or far away the different points are. So we have a variance here. Here also we will choose variance. So this is variance, maximum, average, and whatever function you want to choose. And to represent that we are analyzing the air quality overview or etc., we can also bring some icon or image here, which will help people in understanding it better. So we will simply use image here. We have our simple image. This image is available on Canva. So from Canva, I have downloaded it and we are just representing it here. Or you can use different type of image to represent different parameters. That's your choice. Now, we also have some important parameters like relative humidity, temperature, and absolute humidity. So let's say we want to see the effect of temperature on any value here. Like let's say we are getting from sensor 1 CO, from sensor 3 NOx, from sensor 4 NO2. So if you will see PTO8S1CO is a categorical value, hourly averaged sensor response, normally CO targeted. Okay. So what we are going to do here, we will create a simple line chart here or a scatter plot. And in the scatter plot, you can see the effect of different type of temperature related fields. For example, temperature here, atmospheric fields like temperature or relative humidity. So in x-axis, we will bring temperature. Let it be sum of T for now. On y-axis, we are going to bring uh, the sensor value PTO8S1, and this will give you something like this because it is summarizing the data. We will say don't summarize, and here also we will say don't summarize, looking like a cloud. So you have the distribution, and you can see we have one outlier value here, minus 200, and temperature as minus 200. This can't be true. Like maybe because of some kind of error it may be. So what we can do, let's say temperature is all. We can do something like is greater than minus 200. If you want to keep these type of outlier values, you can keep, but you can apply. And this way, you will be able to see distribution like this, right? So here we have temperature versus PTO S1CO, and you can also do trend analysis here. You can bring the trend line and see. So for all the values that we have, you can see if temperature is increasing, what is the effect on sensor 1 CO value. Okay, you can also, if the trend line is having a positive slope, you can say they both are directly proportional to each other. When one is increasing, other is also increasing. If they have a negative slope, you can say the inverse of that. And here, let's say instead of this value, we can also see, benzene. So we'll say don't summarize. So you can see its effect. So on the basis of this, you can put different type of parameters here. And for example, let's say you want to see the effect of temperature on absolute humidity. So you can put that as well and say don't summarize. So here you can see when temperature increases, absolute humidity also increases, right? Although the effect is not directly which we can get here, but you can see the slope of this line is upward. You can also go and choose a particular color for it so that you can see the line properly. And this is showing T versus AH. So you can write something like temperature versus absolute humidity, or we can add temp versus absolute humidity. This way you can see effect of one numerical value on the other numerical value, and we can select this, go to home and copy its styling and paste here. And if you want to bring, you can also bring some images for these charts representing what you are doing. This is just temperature versus absolute humidity, which I have created with the help of chat GPT. So these type of icons, kind of make your charts more meaningful. These are optional. Now, other thing that we can do is we can also view sensor performance. So you can create a separate chart for it with multiple scatter plots. So you can use a scatter plot, that is sensor reading, let's say PTO S1CO versus its pollutant value. You will be able to see the relationship between it. So if you will go to chart, for example, we already studied this is hourly average sensor response, normally CO targeted. Okay, and this is COGT, the hourly average concentration of CO. So This is reference analyzer, and this is value from the sensor. So for that, we will simply make a copy here, and we will get rid of this. And here, what we are going to bring, let's remove temperature and absolute humidity here. We will, on x-axis, we will bring the reference, let's say COGT, okay, and on y-axis we will bring PTO8CO, and we will say don't summarize, don't summarize, okay. So this way we will be able to see the value. Obviously it is saying for COGT minus 200, it is showing different value. For COGT 0 onwards, it is showing some values. And as I said, if we these are kind of outliers, so if you want to see the performance here, so here we selected temperature, so we will remove temperature filter here, and let's say because COGT is on the x-axis, let's say we choose it greater than, so is greater than minus 200. Let's apply. Here you can see a linear trend. Obviously, in some cases that is not evident, but in most of the cases, most of the data points, you can see uh, with reference to COGT, sensor value are very much related to each other. So this way, you will be able to see a scatter plot, that is sensor reading versus pollutant concentration. This will evaluate sensor reading and their correlation with actual pollutant measurement. You can keep, create a copy of this and create it for separate charts. So let's say we want to see it for, first of all, I will change the heading, because here we are using it for, let me remove it. Here we are doing it for CO sensor versus COGT. Or you can write whatever you prefer, but this is letting us know about that. And let's say for CO, this particular gas, we are going to select a different color for our marker. You can also select a different type of marker shape. For example, we can select something like a triangular value, and this is series. So we will choose a different color. Let's say for this we will select this color. Okay. Similarly, we will create another copy here, and here we can create. So this was CO sensor versus COGT, and here we will remove it, and let's do it for NO2. So we have NO2 sensor which we will put on y-axis, and NO2GT, which is the reference value which we will put here, and here also we will say don't summarize. Here also we'll say don't summarize. So you will be able to see in this case, and this is NO2 sensor versus NO2 GT. So you can create separate dashboards for it, and in the similar way you can analyze it for them. Here also, if you want, you can remove it with a filter. Here we have CO2, so here we will say NO2 is greater than minus 200. Now we are just applying this filter to see for most of the values, and apply. Here also we can see a linear trend, but not quite evident at this. And here also we will go to visual setting, and we are going to select a different type of marker here. Different type of shape can also be selected, just to make the graphs look different. And here in color, let's choose a light color, light blue, or let's say this one. So we have NO2 sensor versus NO2 GT. And since we are doing it for benzene, NO2 and CO, so we will use them also. And later you can see the effect of different atmospheric features like temperature, relative humidity, and atmospheric humidity on different type of gases, pollutant gases that may affect the air quality. You can see if temperature increases, the will that affect CO, will that affect benzene concentration, etc. And here uh, on x-axis we will bring C6H6GT, and on y-axis we will bring from sensor. So we don't have it, so we will remove and we will bring for NOx. So we will bring it here and we will bring NOx GT. The idea is just to understand if all the values are numerical, then you don't summarize. Here, here you can see the value, the actual value when this is increasing, the actual value from the sensor is actually decreasing. So this way you will be able to see the relationship. And this is NOx GT versus sensor value. So this is the first dashboard we have built. This is the first part. Obviously, we have air quality analysis like Gauss chart show current AQI values based on pollutant threshold. We can do some missing data analysis, bar chart with frequency distribution of good, moderate, unhealthy, etc. This is something that we are going to perform in the next part. So please subscribe to our channel if you want to see more detailed analysis. If you want to learn more Power BI application of Power BI on real data sets, and this will help you in learning the concept of building different type of dashboards. So see you in the next video. Thanks for watching this one.